Imagine a car that never needs to shift gears. No upshifts, no downshifts, no transmission at all. For over a century, the gearbox has been one of the most complex and essential components in automotive engineering. Entire industries were built around it. Millions of engineers spent decades refining it. And yet, what if all of that complexity was never truly necessary? What if the gearbox wasn't a solution, but a workaround? Because today, a new kind of machine is quietly rewriting the rules of motion. One that doesn't need gears to accelerate, doesn't rely on mechanical ratios to perform, and might just make one of the greatest inventions in automotive history obsolete. For as long as cars have existed, they have depended on a simple but unavoidable truth of physics. Engines are weak unless they are spinning fast. The internal combustion engine is not a flexible machine. It doesn't deliver power smoothly across all speeds. Instead, it lives within a narrow operating window, a specific range of revolutions per minute where it performs efficiently. Too slow, and it stalls. Too fast, and it destroys itself. This limitation shaped everything. Early engines in the late 19th and early 20th centuries produced very little torque at low speeds. They struggled to move a vehicle from a standstill. But once spinning faster, they became significantly more powerful. So engineers faced a problem. How do you keep the engine in its optimal range, while the car itself needs to operate from 0 to highway speeds? The answer became the gearbox. At its core, a transmission is not about speed. It is about translation, converting the narrow, inefficient power band of an engine into something usable across a wide range of driving conditions. Low gears multiply torque, allowing the car to start moving. High gears reduce engine speed, allowing efficiency at cruising speeds. Over time, this system evolved into something incredibly sophisticated. Manual transmissions gave drivers control. Automatic transmissions added convenience. Dual clutch systems introduced lightning-fast shifts. Continuously variable transmissions tried to eliminate discrete steps entirely. Each iteration was an attempt to solve the same fundamental limitation. The engine itself was never good enough on its own. And so the gearbox became a kind of mechanical translator, a mediator between what the engine could do and what the driver demanded. But this solution came at a cost. Gearboxes are heavy, they are complex, they introduce friction, heat, and energy loss. In fact, in many traditional vehicles, the transmission alone can account for 10 to 15% energy loss between the engine and the wheels. That's a significant inefficiency in a system already constrained by thermodynamics. Yet the industry accepted this compromise, because there was no alternative. Or at least, there wasn't one for over 100 years. And this is where the story becomes interesting. Because everything about the gearbox, its complexity, its necessity, even its existence, is based on a single assumption: that the engine needs help. But what if a motor didn't? What if the source of power itself didn't have a narrow operating range? What if it could deliver full torque, instantly, at any speed? Would you still need a gearbox, or would the entire concept simply disappear? To understand why the gearbox existed, we have to confront a deeper truth. The internal combustion engine is, in many ways, an imperfect machine. Not because it lacks power, not because it lacks refinement, but because it operates under severe physical constraints. The tyranny of RPM. An internal combustion engine does not produce power in a linear way. Instead, it behaves more like a narrow-band instrument. At low RPM, there is barely enough torque to overcome inertia. At high RPM, efficiency drops, friction rises, and mechanical stress increases dramatically. Somewhere in between lies a sweet spot, a narrow band where the engine produces optimal torque and efficiency. This is known as the power band, and it is incredibly limited. For most engines, useful torque might exist between, say, 1,500 and 5,000 revolutions per minute. Outside of that range, performance collapses. But here's the problem. A car doesn't operate within a narrow range. It needs to start from zero. Climb hills, cruise at high speed, accelerate rapidly. That's an enormous range of demand for a machine that only works well in a small window. So engineers had no choice. They had to stretch that narrow band across the entire driving experience. And that's exactly what the gearbox does. Mechanical multiplication. A gearbox is essentially a system of ratios. Lower gears multiply torque but limit speed. Higher gears reduce torque but allow higher speeds. It's a trade-off. Always a trade-off. When the car is starting from rest, it uses a low gear to amplify torque. Without it, the engine simply wouldn't have enough force to move the vehicle. As speed increases, the gearbox shifts into higher ratios, reducing engine RPM while maintaining wheel speed. This allows the engine to stay within its optimal operating range, even as the car's speed changes dramatically. But every shift is a compromise. Too early and the engine struggles. Too late and efficiency drops. Even in modern automatic transmissions with advanced control systems, the gearbox is constantly juggling competing priorities. Performance versus efficiency, smoothness versus responsiveness, durability versus complexity. It is not a perfect system, it is a necessary one. The hidden cost of complexity. What makes this even more fascinating is the sheer complexity required to make this system work. Inside a modern transmission, there are multiple gear sets, clutches and synchronizers, hydraulic systems, electronic control units, all working together to manage torque flow in real time. It's a mechanical symphony, but it comes at a cost. Every gear mesh introduces friction. Every clutch engagement generates heat. Every moving component adds weight and potential failure points. And perhaps most importantly, every stage of power transfer reduces efficiency. By the time energy leaves the engine, travels through the transmission, and reaches the wheels, a significant portion has already been lost. In some cases, as mentioned earlier, up to 15% of usable energy disappears inside the drivetrain alone. And that's before accounting for the inherent inefficiency of combustion engines themselves. A workaround, not a solution. This leads to an uncomfortable realization. The gearbox is not an elegant solution. It is a workaround. A brilliant one, certainly. Refined over decades, engineered to near perfection. But still, a workaround. It exists because the engine cannot adapt. It exists because torque is not available when needed. It exists because power must be reshaped, retranslated, and redistributed just to make the system usable. And that raises a fundamental question. What if you remove the limitation at the source? What if the power unit itself didn't need to be managed? No narrow power band, no dependency on RPM, no need to stay in the right gear. Would all of this complexity still make sense? And this is where everything begins to change, because a different kind of machine has already answered that question. Not with better gears, not with smarter transmissions, but by eliminating the need for them entirely. And this is where the story takes a decisive turn. Because while the automotive industry spent decades perfecting transmissions, another technology emerged that quietly made them irrelevant. Not by improving the gearbox, but by eliminating the problem it was designed to solve. A completely different kind of machine. Electric motors do not behave like internal combustion engines. They don't rely on explosions. They don't depend on air, fuel, or ignition timing. And most importantly, they don't have a narrow power band. An electric motor can deliver maximum torque from 0 RPM. Instantly. No build-up, no waiting, no need to rev up. From the moment the motor starts spinning, full torque is available. And as speed increases, power delivery remains smooth and continuous across a far wider range than any combustion engine could ever achieve. This single characteristic changes everything, because the original reason for having a gearbox simply disappears. No translation required. Remember what the gearbox was doing. It was translating a weak, narrow-band engine into something usable across different speeds. But an electric motor doesn't need translation. It already operates efficiently across a broad range. It doesn't stall at low speeds. It doesn't struggle to deliver torque from rest. It doesn't require multiple ratios to stay in the power band. Because in a sense, it has no power band. Or rather, its usable range is so wide that the concept becomes almost irrelevant. This allows most electric vehicles to operate with a single-speed transmission, or in some cases, no traditional transmission at all. Just a fixed gear reduction between the motor and the wheels. Simple, direct, efficient. Software replaces mechanics. But the real revolution is not just in hardware. It's in control. In a traditional vehicle, torque delivery is constrained by mechanical systems, gears, clutches, hydraulic controls. In an electric vehicle, torque is controlled by software. Algorithms regulate current flow to the motor in real time, adjusting output with incredible precision. Instead of shifting gears to change torque, the system simply changes how electricity flows. This happens in milliseconds, faster than any mechanical system ever could. And this opens the door to capabilities that were previously impossible. Instant torque vectoring between wheels, seamless acceleration with no shift shock, adaptive control based on traction, terrain, and driver input. The drivetrain becomes less like a machine and more like a dynamic system. Efficiency and simplicity. By removing the gearbox, electric vehicles eliminate one of the most complex and loss-prone components in the entire drivetrain. Fewer moving parts, less friction, less heat, less maintenance. Energy flows more directly from the battery to the wheels, and that translates into real-world efficiency gains. Where combustion engines struggle with thermal efficiency, often below 40%. Electric drivetrains can achieve system efficiencies well above 80 to 90%. And because there is no need to constantly shift gears, acceleration becomes smooth, uninterrupted, almost linear. It feels different. Not just faster, but fundamentally more direct, but not completely gone. Yet, interestingly, the gearbox hasn't completely disappeared. Some high-performance electric vehicles, like certain models from Porsche, still use multi-speed transmissions. Why? Because at extreme speeds, even electric motors face efficiency trade-offs. A second gear can improve high-speed performance and efficiency in specific scenarios. But these are exceptions, not the rule. For the vast majority of electric vehicles, a single-speed system is more than enough, which tells us something important. The gearbox is no longer essential. It has become optional. And that's a profound shift, because for over a century, the gearbox was not just a component. It was a necessity. Now it's becoming a legacy. And this raises the biggest question yet. If electric motors eliminate the need for transmissions, what does that mean for the companies, the engineers, and the entire industry built around them? For over a century, the automotive world was built around a single assumption. Power needed to be managed. And so companies engineered increasingly sophisticated ways to control it. Manufacturers like Toyota refined hybrid systems with planetary gear sets that could seamlessly blend engine and motor output. Brands like Volkswagen invested heavily in dual-clutch transmissions, capable of shifting in milliseconds. Performance icons like Porsche turned gearboxes into precision instruments, mechanical masterpieces designed for speed and control. Each of these systems represents decades of engineering excellence. But they all share one thing. They exist to compensate for the limitations of combustion. Electric vehicles take a radically different approach. Instead of managing power, they redefine it. Companies like Tesla built their entire architecture around simplicity: high-torque electric motors, single-speed reduction gears, and software-driven control systems. No shifting, no gear hunting, no mechanical compromise. And the result? Faster acceleration, higher efficiency, lower complexity. But this shift goes far beyond performance. It reshapes the entire supply chain. Transmission manufacturers, once critical to the industry, now face an uncertain future. Entire categories of components are becoming obsolete. Engineering priorities are changing too. Mechanical complexity is being replaced by software intelligence. Precision machining is stooping to algorithm design. And the skill set required to build a car is evolving in real time. So the question is no longer whether electric vehicles are better or worse. The real question is this: if the gearbox is no longer necessary, what else have we been building around the wrong idea? For over 100 years, the gearbox stood as a symbol of human ingenuity, a solution to a difficult problem, a bridge between limitation and possibility. It transformed fragile, inefficient engines into machines capable of crossing continents. And for a long time, it was indispensable. But history has a way of revealing uncomfortable truths. Sometimes the most brilliant solutions are built not because they are ideal, but because they are necessary at the time. The gearbox was never the destination. It was a workaround, a beautifully engineered answer to a flawed question. Now, as electric motors redefine what a powertrain can be, that question is being rewritten, not gradually, but fundamentally. And this is what makes this moment so significant. Because we are not just witnessing the evolution of a component, we are watching the disappearance of an entire category of engineering. No gears, no shifting, no translation, just pure, immediate motion. And maybe, just maybe, the future of the automobile was never about adding more complexity, but about realizing it was never needed in the first place.